Okay, so I think we're recording now. So just waiting to get the split screen. Here we go. So this is our 5th revision lesson. Okay, so as you can see from that schedule that you should be familiar with now, we're going to be revising angles today. So quite a bit of easy stuff to start off with that I'll just rattle through nice and quickly. And then a few questions that you can just really quickly have a go at. Then we'll move on to things that are slightly more challenging. So, as you remember, if you turn all the way around, angles about a point, they add up to 360 degrees. That's a whole turn. And obviously going halfway round, which generates a straight line, that's a half turn. So that's why angles on a straight line total 180. And then just on a similar vein, if you're doing a quarter turn, that generates a right angle. So that's why 90 degrees in a right angle. And then the 4th thing we're aware of, that the angles in any triangle, the 3 angles will total 180. And then in a special triangle, so in an equilateral triangle, all 3 sides are the same and all 3 angles are the same. So all 3 angles are 60 degrees. And remember, with an isosceles triangle, we have the 2 sides which are the same, not 3, and the base angles of that isosceles triangle are equal. And then a quadrilateral, that just means a 4-sided shape. Remember that really, if you just take any corner and join it to the opposite corner, that generates 2 triangles. The angles in each of the triangles add up to 180. So overall, the angles in a quadrilateral must add up to 2 lots of 180, which is 360 degrees. So I'm just going to pause here, guys. I would like you just roughly, just like I've done here, can you just get some paper and just sketch those? You're allowed to use your calculator and just quickly work out what those missing angles are across those shapes. I'll give you a couple of minutes to do this before we move on to something a bit more challenging. But I'm just going to pop out and get a cup of tea. Okay, I'm back. So let's go through these. So obviously angles on a straight line add up to 180, so x must be 130. And here, angles in a triangle add up to 180, so A must also be 50 rather. The 60 and 70 is 130, and the 50 gives you 180. And then over here, these angles in a quadrilateral add up to 360. So 360, take away these three, you should have got 70. All three sides of this are the same, so this is an equilateral triangle, so every angle is 60. And here we've got an isosceles triangle, so these two base angles must be the same. That's 30, so these must together add up to 150. So share 150 across the two angles, that gives us 75. Excuse me. So angles about a point add up to 360. So 360 take away 170, take away 85, take away 40, gives us that angle there, 65. Now this one you need to do a bit more work. So angles in a straight line add up to 180, so that must be 60. And again on a straight line add up to 180, so that must be 70. 60 and 70 is 130, so that must be 50, which is the difference. So hopefully you remember all of that stuff, all quite straightforward really. Okay, then the next angle property that we reminded ourselves, when you've got a couple of parallel lines, and we know they're parallel because we've got this arrowhead, then if you're given this angle here, and you need to work out this angle here, it's also 40 degrees. It's sort of casually called the Z-angle rule, but the formal terminology is alternate angles are equal. So picture one person looking that way, that person's looking the other way, so alternate angles are equal. So same parallel lines, but if the information was such that you were given this angle here and you needed this angle here, because that sort of forms a falling over F, it's the F angle rule, so Y must also be 80 degrees, but we say corresponding angles are in the same way. So then I think it's the final rule from memory, where you've got two straight lines crossing, opposite angles are equal, but we've got to be more precise than that nowadays. We've got to say vertically opposite angles are equal, so that would be 110 degrees. Now, this is where I wanted to spend a bit more time, us remembering how to do exterior and interior angles. So just bear with me, I'm just having to take my keyboard off now. Using my pen. So I wonder if you can remember where we're going to be going with this. So just do a really quick sketch of a rough six-sided shape, a rough hexagon. So just a six-sided shape, and just extend the lines coming out. You don't have to use a ruler, you can just do it roughly. Now, what we are saying, as you would probably imagine, that is an interior angle. Let's call that I for interior. Interior means inside. Like if you're an interior decorator, you decorate the inside of a house. Now, because this line is just extended, this angle here is called the exterior, the outside angle. So let's call that E. So E is an exterior angle. And as you can see, these form a straight line. We know that angles on a straight line total 180. So rule number one that you need to learn, and as long, if you can remember why, it makes it a lot easier to remember. So rule number one is that the interior angle plus the exterior angle of a regular shape, and by regular shape we mean all the sides are the same length, all the angles are the same. So the interior angle plus exterior angle equals 180 degrees. And as I said, easy one to remember because you can see they're forming a straight line, and angles on a straight line add up to 180. So that's the first rule concerning exterior and interior angles. Now, if you remember what we then moved on to, I wanted you to imagine that you were looking down from above, okay, and this was like a base for a rocket blasting off into space. And as you look back from a very long way away, that hexagon has sort of just become a tiny, tiny little dot far down on the ground. But you've still got all of these exterior angles, that you can still see. So all of these exterior angles, these outside angles, all of these you can still see because these lines go on forever. So imagine it's a bit like the Great Wall of China. They say you can see that from space. So what can we say about all of those exterior angles when they're added up? What can we say about the total of the exterior angles? Well, you can see they form the angles on the point. You can see they add degrees. So our second rule, so our rule number 2, is that the total of the exterior angles equals 360 degrees. Okay, the total of the exterior angles equals 360 degrees. So we've got these two rules. We've got rule number 1, that interior plus exterior angle equals 180. And rule number 2, that the total of the exterior angles, equal 360 degrees. So on the back of that, I want you to go and see if you can work out for a 6-sided shape, so like the hexagon that we've got at the moment, can you work through the various steps to enable us to work out what each of the interior angles would be? So I'm just going to give you a few seconds to think about it. I'll just give you a clue. The opening statement, your opening thought is that the exterior angles always add up to 360. So get that written down. It's a 6-sided shape. So see if you can work through using that rule 1 and that rule 2 to figure out what each interior angle must be. Okay, I might help you out with this one quite quickly and then give you a bit more time on the other examples. So if the exterior angles total 360, now it's a 6-sided shape, so it's got 6 exterior angles. So each of the exterior angles must be 360 divided by 6. Okay, so let's think about it. It's a 6-sided shape. Exterior angles always add up to 360 for a regular shape. It's got 6 sides, so that means it's got 6 of those exterior angles. So if they add up to 360 in total, and there are 6 of them, each of them must be 360 divided by 6, which is 60. So that's really using rule number 2, isn't it? The exterior angles total 360. Now, once we know that the exterior angle is 60, how can we work out what each interior angle is? Well, that must be taking it away from 180, because remember, interior plus exterior equals 180. So if the exterior is 60, the interior must be 120, because these two together have to add up to 180. So please could you work through a similar process for a regular 12-sided shape? I want you to go and work out what each of the interior angles must be. So I'll just give you a bit of time to think about that. For a 12-sided shape, we'll just work through the points, how we're going to work out what each of the interior angles are. Okay, so let's work through it. So we're saying the exterior angles, as we know, always add up to 360. It's a 12-sided shape, so it's got 12 exterior angles. So each of those exterior angles must be 360 divided by 12, which is 30. And if each of the exterior angles is 30, what must be each of the interior ones? Well, because we're up to 180 together, that must be 180 take away 30, which is 150 degrees. Okay, so can you, another one please, work out the size of each of the interior angles for a 36-sided shape? Okay, so as always, for a regular shape, the exterior angles add up to 360. Because it's got 36 sides, it's going to have 36 exterior angles. So each of them must be 360 divided by 36, which is 10. Now that's the angle on the outside, that's the exterior angle. So the interior one must be 180, take away 10, which is 170. Now, what I've got here is a whole succession of questions and answers. So what I propose to do, because I don't want this video to become too long, I am just going to give you a few seconds on each of the questions. Not enough time for you to do them now, but enough time for when the video is processed and recorded, that you can just watch the video and stop after each of these questions, and then the answers will come afterwards, okay? So again, what I'd like you to do, please, is to complete these on just a sheet of paper. Then if you could just practice uploading them through to your class notebook page on Teams. And if you could file it under classwork, that would be great. And if you could just drop me a quick note, just a quick email or a quick message on posts on Teams, just to say that you've done it, I will go and have a look and just give your work a bit of a tick. So this is question 1. So pause the video now. Here's the answer. Here's question 2. Here's the answer. Here's question 3. Here's the answer. Here's question 4. Here's the answer. And finally, question 5, just the top bit. I've blanked out the other bit, we don't need to be able to do that. And here's the answer. Okay, so I can't remember if we have a lesson tomorrow or not, guys, do we? Let me have a quick look. We do, yes, so we will have a lesson tomorrow, so I will see you guys again tomorrow. So if you just go and wait 10 minutes, this video will process and upload onto the Teams posts page. So you know that page where you're all saying hi before the lesson begun. So just give it 10 minutes to upload. I'm also, as I think I've said, I'm uploading them onto YouTube. So if you're struggling to get onto Teams, then they're just on my Maths by Mr. Withers under third form remote lessons. Okay, guys, so well done. If you're going to chat afterwards, feel free to do so, but wait until I've finished the recording. But do just bear in mind that this is a school platform, so any of the teachers could be listening in. So no, nothing silly, please. All right, so bye, guys. I'm just about to close the lesson. I'm going to stop recording in a second.